could tables be a viable way of implementing programs and user interfaces? This is the question I've asked myself a few months ago, and this is what we'll look at today. A toy, an experiment if you want. So don't expect a lot of things, just a fundamental demo of a concept. Welcome back to Think Design Works Smart. I'm Alex Bolboaca and I'm coming at you from the Mozaic Works studios. And what I have for you today is a demonstration of this concept that I thought about a few months ago when I was working on some extensions to Google Spreadsheets for our automation. And I realized that maybe we can have user interfaces and also computation based on tables. Now, this is a bit of a weird idea. Okay, this is not a normal video for today. And one of the reasons I'm doing this is it has just been my birthday, so I get to do a video about something a little bit different, okay? But don't worry, we'll resume our work with videos on cybersecurity, software architecture, design, the AI usage for software development. We'll get back into that. But it's January. It's close to my birthday, so let's look at something that might be interesting. I don't know. You let me know. So I implemented this small thing. Basically what this is a Python script that starts a TCL-TK, well, a TK application. And as you can see, you have a number of cells. Doesn't matter, we can make more cells. But what I wanted to do is to test something really simple. So here are the rules that I've implemented. Each cell can have a value and a formula. The value is the initial value. The formula is what applies. After you introduce values, formulas, and so on, you can click on calculate and calculate iterates. So it basically takes, if you have a formula that needs input from other cells, then it would compute the result, but it doesn't look for changes in the other cell. Rather, you have an iteration, it computes the next values. If something changes, it will realize in the next iteration because it will compute again. And the whole thing stabilizes when the values stay the same. So when the values don't change anymore. Okay, a little bit of a weird concept. But what I'm thinking about is that maybe this is a way to implement certain types of applications. And yeah, I know it might sound weird for software developers, for programmers, but you know, Excel is a programming language. So I was just looking at ways to make it a little bit more interesting. So you can go here and say, I want a value. If I want just a value, it will have a value. I want another value, okay. And then I want, let's say I have a value, but I want to have E8 plus E9. And this will give a result. As you can notice, the result is not computed now, so I click on calculate. It has stabilized after 2 iterations because basically it did 1 iteration made the computation, then it iterated again and it saw that nothing changes. Okay, that's interesting. Now imagine that you have this like this, first value, I still haven't figured out how to use enter and escape in these dialogues. And total. And now you have a very simple user interface. You have labels, which are basically string values that you play somewhere. You have the values and you have the sum. Okay. Now the functions that I've implemented here are very, it's a very small subset. So we're only gonna see a few of those. So now let's do something a little bit more complicated. Let's say we want to do Fibonacci, right? So for Fibonacci, we'll have, let's say Fibonacci n minus 1, Fibonacci n, actually no, so it should be n minus 2, n minus 1, and Fibonacci n. And now we'll have, first we'll have 0 to start and 1. And this needs to be E8 plus E9, indeed. The same thing. Basically reset now. And now n minus 2 needs to become the n minus 1, so this would be E9. And actually, no, actually what we need to do is n minus 1 and n. Let's see. I did this before, but it's a bit weird to do this. Okay. So this needs to become E9. This needs to become E8 plus E9. Okay. Calculate. As you can see, it iterates and it keeps computing things, and we end up with 5589. Actually, I don't need this one. This one was extra. All right, if I do again, calculate 5589, and those are the actual Fibonacci values, but they are, it iterates pretty quickly. Now I have set a maximum iterations because in case you get an infinite loop, and this can be higher, like 1,000, it doesn't matter. I just did 10 to see something. Okay, so this is how you do recursivity. So because we have recursivity, we have loops. The next thing we can do is to have conditions. How do we implement conditions? Well, let's do something a little bit different. Let's say we want to, and actually let's try something that I didn't try. First number, second number. Let's try to have multiple computations. And total. We'll see live if this works. Or if something breaks. So let's make it 0. And then I guess it's J10 plus J11. No, it's J11 plus J12. No, it's Q. Gosh. professional programmer, K11 plus K12. And let's now do calculations in parallel. As you can see, this one stops after 2 iterations, the other one continues. So it basically keeps on computing the whole board, but the things that stabilize, we can optimize those so that they are not computed again. And the others, and I think it is optimized. They don't compute again, but the others are keep on computing. Okay, so now imagine you have an area of this which is the input data, and maybe you can read that input data from somewhere, from files, from web services, from whatever you want. Because maybe you link those with custom functions. And then you have the program, and at the end you get a result. And the result is with this set of values that stabilizes. All right, now let's look at another thing. So maybe we want to do some kind of condition, right? And let's make this fun. Let's say we have a dice. And let's do, now let's see if I can remember how to do this. So it's randint, no, randint. Okay. Randint 120. So maybe we do a D20. And then we'll say something like result. Okay. So maybe we have something like we'll say nothing, but then we have hit if, or let's do critical hit if K16 equals or let's say greater than 18 or equals 20, else hit. Invalid formula. Do we need? Yeah, we need 2 equals. Okay. So now we have nothing. Let's calculate, and you can see hit, critical hit. Now we got 10 iterations. So this one is keeps on running, and all of these things update independently. Now imagine also that you add some kind of a parallel implementation. Right now this runs in a single process, single thread, but you could theoretically have areas, and each area runs in a process or whatever. You can do all kinds of things. And then at the end you might have something that connects to the outside world, maybe sends an email or creates a table, or I don't know, stores the value somewhere. All right. So what we have here is we have simple formulas, simple operators, simple formulas. We have conditionals. We have recursivity, which means that we can have cycles. And what this means, and we have iterations built in anyway. So based on what I'm seeing, we have a programming language, because the fundamental parts of a programming language are sequence, conditionals, and iterations. And we have all 3 of those. Now let's say you wanted to do something like an object. this is something that I was thinking about. I didn't implement it, but you could take this area and say this is the object Fibonacci, and you mark it as a separate thing, and you mark this as a separate thing as, I don't know, the object sum that does first number plus second number, and you have the third one as dice and hit, critical hit, the RPG stuff. You can basically play around with this. And so what you have is built-in user interface, because you have labels and inputs. You have built-in computation in a programming language. And basically the thing that is missing is input-output with more interesting stuff, like with databases or files or web services and so on. Well, this is just the thing that you could add. Right. So that's it. This was my idea. I found it interesting. I wanted to implement this. And I actually did the implementation using Claude, because there were many things that I didn't quite know. This is a prototype. The code is not great. Don't expect anything that's clean or tested or whatever, or secure or production ready. No, this is just a plain prototype, a toy. It's a toy that I can play around with occasionally. But maybe this inspires you. So what do you think? Let me know in the comments. Is this something that you find interesting, intriguing, not interesting at all? Are there other toys that you'd like to see us implement? Let us know in the comments. Thank you kindly for the view, and until next time, remember to think, design, and work smart. See you next Saturday.